Welcome to This Explainer. Today, I am speaking to you not merely as an analyst, but as a strategic advisor. In the highest echelons of corporate governance, we pride ourselves on being deeply data-driven. Yet a fundamental misunderstanding currently plagues our boardrooms. It is a mathematical misinterpretation that routinely leads to the misallocation of millions in capital. Today, we are going to dismantle this error. We will examine the critical divergence between statistical significance and practical business importance, and I will equip you with a rigorous strategy to achieve calibrated trust in your data. Let us quickly review our methodical roadmap for today. First, the illusion of significance. Second, the strategic risks of binary thinking. Third, demystifying the p-value. Fourth, reframing with confidence intervals. Fifth, AI-augmented analytical solutions. And finally, building calibrated executive trust. We begin directly with Section 1, the illusion of significance. Consider this precise business scenario. Your marketing team runs a rigorous 4-week A/B test on the company homepage. Variant A is your established baseline, while Variant B features a new hero image. After testing hundreds of thousands of visitors, the team presents their findings with immense pride. Variant B, they report, significantly outperformed Variant A. As an executive, you hear that specific word, significant, and naturally assume a major victory has been secured. However, the seasoned vice president of marketing, someone who has weathered many such presentations, asks the most obvious yet absolutely crucial follow-up question. It is a question that cuts entirely through the analytical noise. Exactly how much better? The team consults their data. The answer? About 0.3 percentage points on conversion. Now, observe this stark disconnect here. By the strict mathematical definition the team utilized, the result is indeed statistically significant. But by any reasonable standard of business measurement, a 0.3 percentage point lift might be entirely meaningless. It might not even cover the engineering costs required to implement the change in the first place. This brings us precisely to Section 2, the strategic risks of binary thinking. We often fall into what is correctly identified as the trap. An analyst presents a result as significant, and the executive audience immediately hears the word important. You see, in our everyday conversational language, these two words are synonyms, but in statistics, they occupy entirely separate universes. This linguistic trap leads to a highly dangerous strategic conflation in the boardroom. We end up optimizing trivialities while completely missing substantial opportunities. We must draw a formal, uncompromising distinction here. Statistical significance is merely a measure of chance. It is heavily driven by how large your sample size happens to be. Practical significance, however, is driven by the real world. It is driven by your business context, your revenue targets, and your profit margins. A result can easily be statistically significant, but commercially irrelevant. Conversely, a finding can be practically vital, but statistically inconclusive, simply due to a lack of data. Let us move to Section 3, where we will strip away the academic jargon, demystifying the p-value. The primary culprit behind this boardroom confusion is usually the p-value. Analysts often treat it as a profound metric of truth, strictly adhering to an arbitrary threshold like 0.05. Let us demystify this entirely. The p-value is nothing more than a measure of surprise. It simply asks, if there were genuinely no difference between Variant A and Variant B, how surprised should we be by the data we just collected? A small p-value merely indicates the data would be highly surprising if nothing real was happening. It does not mean the effect is large, and it certainly does not mean the effect is profitable. This brilliantly illustrates the new paradigm we must adopt. Look at these 4 quadrants. On the horizontal axis, we have statistical significance. On the vertical axis, we have effect size, the actual practical importance. The most strategically dangerous zone is the top left quadrant, the statistically significant but practically trivial result. This happens when you have a massive sample size that detects a microscopic, meaningless lift. The second most dangerous is the bottom right, a massive, meaningful business effect that gets dismissed as insignificant simply because the sample size was too small to prove it mathematically. We pivot now to the resolution in Section 4, reframing with confidence intervals. The answer to this dilemma lies in demanding confidence intervals. A binary yes or no test hides reality. A confidence interval reveals it. Instead of an analyst vaguely stating, Variant B is significantly better, the calibrated analyst says, Variant B raises conversion by between 0.1 and 0.5 percentage points. Notice the crucial difference. This single sentence delivers the magnitude, the direction, and the precise level of uncertainty. If that entire interval sits below your business's threshold of profitability, you instantly know to reject the initiative, completely regardless of its mathematical significance. This brings us to our true competitive edge in Section 5, AI-augmented analytical solutions. Implementing this rigorous thinking across an entire enterprise is remarkably challenging. This is precisely why we must leverage artificial intelligence not just for baseline computation, but as a highly capable strategic reasoning partner. You must train your executives to feed specific, sequential prompts to their AI assistants. Step 1, input the raw facts, the effect size in absolute terms, the sample size, and the interval. Step 2, force the AI to evaluate magnitude. Ask it, is this difference actually large enough to matter for our specific business scale? Step 3, prompt for critical thinking. Ask, what additional contextual information would a thoughtful skeptic require before allocating capital to this finding? I strongly encourage you to try this framework immediately following this explainer. Take a recent A/B test or a customer satisfaction report from your own organization that was previously heralded as significant. Process it through this AI-augmented workflow. You will instantly notice how the AI's analysis pierces right through the misleading binary framing. It surfaces the contextual, business-centric questions that truly matter for your operational strategy. We conclude our framework with Section 6. Building calibrated executive trust. When next your teams present a significant finding, you must demand this strategic toolkit. 1. What is the exact size of the effect expressed in hard business terms, not just abstract percentages? 2. What is the confidence interval, meaning what is our actual range of uncertainty? 3. Was the sample size so massive that it merely detected a microscopic, irrelevant truth? And 4. Crucially, is the size of this effect actually large enough to justify the engineering and operational capital required to act upon it? The statistical significance verdict was never designed to answer the fundamental question that business demands of it. Business asks whether or not to act, and action requires evidence of absolute magnitude, not just a mathematical probability of reality. So, I leave you with this deliberate challenge. In your very next board meeting, when the slides are presented and the data is touted, will you passively accept a merely significant result, or will you enforce this rigorous new paradigm, leverage your AI reasoning partners, and demand a calibrated truth? Thank you for your focused attention during this explainer. Ensure you bring these critical questions into your next executive alignment.